Okay, so hello and welcome to this week 10th now. So, we are moving to week 10. So, in this week the first video will still continue the wastewater discussion which we were having in the last week. We have not completed the discussion yet. So, part of that first video will focus on that, and then and as you know, the topic was on wastewater. So, we will complete that topic, and then we will move to the new topic in this week, which is on solid waste management. So, let us start from where we left in the previous week. In terms of the wastewater, we were talking about secondary treatment process. So, as part of the secondary treatment process, we did look at the aerobic part, and then we were talking about the aerobic process. So, one of the important process which is very common when we talk about aerobic wastewater is on activated sludge. So, in this video we will focus on activated sludge process, try to understand what it is, how it is used, why it is used, and then we will talk about the disposal of sludge, which is kind of completes the wastewater overview. So, if you remember from the previous video, we were talking about what is known as the trickling filter. So, trickling filter, we have the primary settlement sedimentation tank. Then wastewater goes to the trickling filter. You can have series of trickling filter, and after that we will take the waste to the secondary sedimentation tank, and then finally it goes to a affluent. So, when we talk about the single stage trickling filter, these are again you have a primary clarifier, trickling filter, you bring the circulation back, and then when you do this waste circulation back, that helps you to bring. So, when we talk about this secondary clarifier, so we take this part of the sludge. So, this part of the sludge is actually brought it back. The reason we want this sludge to be back, because it has a good microbial population. So, this microbial, doesn't, let me write it again, microbial, which is essentially the bugs, which has a good amount of microbial population. So, we want this population to be back in here, so that the reaction will be faster. We want this microbes to be present in that in a good population, so that the reaction will be faster. Two stage, you can again have two stage where you have recirculation happening within the first trickling filter, then the second trickling filter. So, okay, then we kind of focus on this sludge. So, this what we talked just now was on what we covered towards the end of the last video. Then after the other process of doing wastewater treatment in terms of the secondary wastewater treatment is what is known as the activated sludge process. In terms of activated sludge, it's a sludge containing a large concentration of highly active aerobic microorganism. So, that is why it is called activated sludge. So, we try to keep them active. Like how we will keep them active? The principle is it is a mixed with raw sewage along with large quantity of air for around 4 to 8 hours in an aeration tank. The settled sludge in the secondary sedimentation is called activated sludge, because it is again recycled to the head of the aeration tank to be mixed with the sewage being treated. So, this activated sludge has a very good population of microbes. It has a high population of microbes. So, this high population of microbes is like a microbial population is brought back into the reaction. You have a good amount of microbial population, which you bring it back to that reaction, and then it is recycled to the head of aeration tank again to be mixed with the sewage which is being treated. So, that is called activated sludge process. So, we have the primary storage tank, then we have aeration tank, we have secondary storage tank, and the chlorination, secondary sedimentation, primary sedimentation tank, and then finally chlorination. So, this aeration tank, so after primary sedimentation tank, this aeration tank plus secondary sedimentation tank, it is kind of part of your activated sludge process, where this aeration tank is called the activated sludge tank, and then secondary sedimentation is where the sludge will come down bottom, and then you take this activated sludge from this secondary sedimentation and bring it back to this aeration tank. So, it is basically taken it back over there. So, that is then you can take some sludge is removed, sludge also is removed from here, sludge will be digested. Before you send the affluent, you need to do chlorination and all that, which we talked about earlier as well. So, This part is called the activated sludge process, where you have the aeration tank and the secondary sedimentation tank. So, what is the component? So, here you have in terms of the activated sludge process, this is the primary affluent coming in, that is the aeration tank. So, we are doing a lot of this is the air compressor, which is doing a lot of aeration. So, we are adding a lot of air, and that air helps in breaking down those organic matter. So, aerobic bacteria are very happy to do that. Then we take this final affluent in this clarifier, where the sludge will come at the bottom. So, sludge will be taken out, and part of the sludge will go back in here as a return sludge, and part of the sludge actually kind of goes to digester as well. And then the clean water, which is the secondary affluent, will be taken out. So, this is the basic component. So, you do not have to worry, since it's a basic environmental science course, as you know. It is not a hardcore environmental engineering course for a civil engineering student. So, we will not go in great detail here, because that is not the mandate for this course. Those who are interested in great detail about the wastewater treatment, there is a separate NPTEL course, I think I mentioned it earlier as well, which is offered by one of my colleague who is an expert in this field. Professor Manoj Tiwari's course is there, which you can, from IIT Kharagpur, which you can register and take that, and that goes in great detail about the wastewater, and it is like a whole 12 weeks he talks about the wastewater treatment. So, here we are just talking in a week and slightly over a week. So, we are just giving you an overview, because that is what we need for this particular course. So, in terms of some parameters for you to know, like see if what kind of it does, again I keep on stressing on this part throughout the course, that all the topics that we have chosen, which goes into this course component, is relevant for working professional, does not matter whichever field he or she will end up working. Because even you work in an industrial setting, you work for certain like Reliance or big multinational companies, PepsiCo, Coca-Cola, whatever. So, even if you are a project manager of a plant and helping a plant, so this affluent treatment plant, because every plant uses water, and whenever there is a water is used, there will be a generation of industrial wastewater, and that industrial wastewater needs to be treated before you can discharge into the environment in a lake or a river or whatever. So, or you can go for a zero liquid discharge, which is altogether a different concept. We'll not go too much on that, but whatever you do, you have to have a affluent treatment plant. So, a affluent treatment plant, activated sludge, is kind of a heart of that activated is a kind of one of the major component of that affluent treatment plant, industrial wastewater treatment plant or the sewage treatment plant, and that is why we are just giving you a brief overview of how things work, so that nobody can cheat you. When basically the vendors which come, you can ask them some good questions, and then they will know that okay, my client has some knowledge about this, so I cannot really sell him or her anything I want. So, just to get you educated enough so that you make judicious decision. You do not have to become an expert in that, but you have to get a judicious decision, because you will be sitting on a chair where you will have to take certain decision, say 5 years from now, 10 years from now, for certain plants, certain township or whatever which setting you work in. So, in terms of the activated sludge process, what we have things coming from the primary settling tank, as you saw in the previous slide. Things do PST, which is the primary settling tank. From there, the affluent will come to this activated sludge process. So, if you look at the primary settling tank, typically we keep a detention time of around 1.5 to 2 hours. Why detention times are important? Because more the detention time means more volume of tank is required. More volume of tank, more land will be required. So, more cost. So, all those things comes in factor. Then it goes from the primary settling, it goes to the aeration tank, where we, as mentioned earlier, we work in a time frame of 4 to 8 hours. So, in that 4 to 8 hours of time frame, we have to design the aeration tank volume in such a way, so that we can accommodate a wastewater of around 4 to 8, say 6 hours or 7 hours of retention time. And then it goes to the secondary sedimentation tank, which has a typical retention time of 1.5 to 2 hours. So, these retention times are very, very important, because that kind of helps you to decide what will be the size of the tank that you require, and then your final clarifier, which is sludge is coming out. We saw that earlier in terms of how they work. So, now there is some other stuff like bulking of sludge and its control under sick conditions. The settled sludge may contain more moisture than resulting in sludge volume. Due to sludge bulking, it remains in suspension. So, we try to eliminate the industrial wastage, chlorination of the sludge, increased aeration, raising the pH of the sludge and all those kind of stuff. So, there is also a concept of called hydraulic retention time. It is the time that is at as long as what is the time that this our like a the untreated wastewater will stay in the activated sludge. So, it is HRT is defined as an average time for which the sewage flowing into the aeration tank remains in the aeration tank. So, what is the so HRT is your hydraulic retention time. So, it is a sewage that comes into the aeration tank will remain there, that we calculate with the volume of the tank, which we kind of talked about earlier, divided by the rate of sewage flow into the tank. So, V upon Q. So, that is the volume of tank which is there, what you design plus divided by the rate of sewage. So, that gives you the HRT, which is the hydraulic retention time. It is the time which is the average time for which the any sewage flowing into the aeration tank will remain there. So, what is that time? Then we also talk based on that we can calculate how much flow is coming in. So, we know how much is the BOD coming in. We talked about the BOD, biological oxygen demand and all that. So, why BOD is important? Because based on the BOD we need to have the microbial population to degrade. More the BOD means more the organic matter, that means more microbial mass needs to be present. So, we talked about that concept is called food to mass ratio, where it is organic loading, we get the organic loading, the kg of BOD applied per day and how much microorganisms are present. In terms of how much microorganisms is present, we try to get that number using what is measuring MLSS, which is the mixed liquor suspended solid. So, that gives us the amount of like amount of microorganisms present there. Then cell age, like older the cell, more or less active they will be, they become older, the microbes as they become old they are less active. Less active means your degradation rate will go down. So, we need to look at what frequently we need to have kind of newer microbial mass added to the system. So, microbes will it is defined as average time days that a microorganism will spend in the activated sludge process, or how long or how it is in terms of system how long it will be there. And then because if it is too much the activity kind of goes down. So, we need to have newer cells coming in. Sludge volume index, it is calculated as in volume occupied in ml by 1 gram of solid. So, that is around 50 to 150 ml per gram is adopted. So, that is a sludge volume index. And so, that is your activated sludge kind of basic parameters. You do not have to even memorize those parameters, you just need to understand that it is essentially a aerobic wastewater treatment, secondary treatment plant, where we try to get the organic matter degraded with the help of microorganisms in an aerobic setting, and we design several reactors and other stuff based on process kinetics and other things which kind of basic engineering, if you are engineers, basic engineering courses that you have taken, even if you are not an engineer, even if you look at the class 11th, 10th, 11th science courses, that should give you some basic understanding. So, and from there, from the activated sludge, if you remember from the sketch, we take it to a secondary sedimentation tank. So, here the picture shown is of secondary sedimentation tank. So, waste will our waste will settle in this secondary sedimentation tank. So, there are different zones that happens. At the bottom you will have some compressed sludge, then hindered, flocculent, discrete, individually there will be some clear on top. So, that is why water is taken out from the top over here. So, that is called compression settling. So, things will settle at the bottom because of the weight, things will just keep on coming down. So, sludge will be removed from the bottom and affluent will be removed from the top. So, some examples are given here. I could say if a completely mixed activated sludge process is used to treat a wastewater flow of 1 million liters per day, which is 1 MLD, having BOD of this. Biomass concentration in the aeration tank, which is the mixed liquor suspended solid, is 2000 milligrams per liter, that is pretty high. And the concentration of the net biomass leaving the system is 50. The aeration tank has a volume of 200. What is the hydraulic retention time of the wastewater in the aeration tank, and what is the average time for which the biomass will stay in the system? So, if you remember, hydraulic retention time is the volume of aeration tank divided by the flow. So, volume is 200 meter cube, flow has been given as 1 MLD, which is 41.66 meter cube per hour. So, if we can take that, we get 4.8 hours. So, around close to 5 hours each what hydraulic retention time we need to have. Now, mean cell residence time, which was the biomass in aeration tank divided by biomass leaving the system. So, how we will get the biomass in aeration tank? That we get by volume of aeration tank multiplied by MLSS, which is the mixed liquor suspended solid in the aeration tank, which we measure actually in the lab. Leaving the system is the wastewater flow rate, which is going out, and the concentration of solids in the effluent, that gives us kind of biomass leaving the system. So, again 1 MLD mixed liquor suspended solid is given as 2000 milligrams per liter, concentration of solid in the effluent is 50 milligrams per liter. So, we just do all that math, just to plug into that equation. So, 200 meter cube, 2000 milligrams per liter, 1000 meter cube per day times 50 milligrams per liter, and then you get that you have 8 days is mean cell residence time. So, these are the ways you can calculate all those numbers while you are trying to do your calculation stuff. Other way of doing this aeration tank is also people not doing, rather than doing the activated sludge, people also go for oxidation pond, which is we try to take the advantage of the symbiotic relationship between the algae and the microorganisms in the presence of sunlight. Algae will produce oxygen while growing in the presence of sunlight, because algae what it will do? It will do the photosynthesis. As part of the photosynthesis, it will consume CO2 and produce oxygen, and that oxygen will be utilized by microorganism to do the organic matter degradation. So, end products of the process are CO2, ammonia and phosphate, and again these will be utilized by algae. So, it is a pretty like a very nice concept of you can also call the zero waste concept. So, think the mother nature, if you look at the mother nature, the way the systems have evolved in earth over millions of years has a lot of kind of team effort. Things were produced by one, the reject of one species becomes food for another species, and the reject of that particular species may become food for this species. So, things are always being utilized. There is the concept of zero waste is already there in the nature. They try to kind of minimize the waste until we start producing all the garbage, which we will talk about in the next video, where we have really messed up the whole system. So, it's in terms of these are utilized by algae. So, as you can see, symbiotic relationship between algae and microorganisms. Algae will use CO2, produce oxygen, microorganism will use that oxygen and do the organic matter degradation for us in terms of the wastewater treatment, and then they will produce CO2, because since it is an oxidation process, it is an aerobic process, you will have CO2 being produced, which can again be used by algae, and also ammonia and phosphate can be used by algae as a nutrient source. So, it is win-win for everyone. So, these are as you can see over here in this particular schematic here, we have organics, we have plus bacteria. So, we have some organics at the bottom, so you have algae with sunlight producing CO2 and some food, and then that CO2 producing oxygen, consuming CO2. That oxygen is used up by the bacteria to degrade the organic matter, and then we have production of CO2, which can again be taken up by the algae to produce more food as part of the photosynthesis. So, it is a wonderful kind of arrangement which can happen. So, for the oxidation pond, say if you have to design an oxidation pond for a residential colony of 5,000 persons contributing sewage at 120 liters per capita per day, the 5-day BOD is 300, organic loading is given 300 kg per hectare per day, assuming L by B is 1:2, find the detention time if the depth of the pond is 1 meter, sorry. So, length by breadth ratio is 1:2. So, wastewater flow rate 120 liter per capita per day multiplied by 5,000. So, we get around 56.6 MLD. Now, surface area would be Q that will be required is whatever is the flow multiplied by the BOD loading rate divided by the organic loading rate. So, how much it can basically it can take. So, you need surface area around 0.6 hectare. Now, this 0.6 hectare converted to meter square is 0.6 times 10 to the power of 4, and L is given as 2B. So, we can get so we got here B is equal to 55 around, and then approximately L becomes 110. So, volume is and if you look at the detention time will be volume divided by the Q, whatever is the volume and the flow rate. So, volume is 0.6 times 10 to the power of 4 multiplied by 1, because the depth is 1 meter, and the flow is given as 0.6 mld. So, we convert that. So, we get a detention time of around 10 days. So, in 10 days the reaction has to happen. So, we should have enough microbial species to eat all those reaction and produce biogas, like produce CO2. It is a aerobic system, it is not biogas will be an anaerobic system, and then use that. So, you will have this CO2 being produced, and at the same time you will have some solids left, which is known as sludge. Now, this sludge or biosolids, as people call it, it needs to be used for it has a different, it has to be also managed. We have to manage this sludge. So, sludge kind of is a semi solid. So, right now we were talking about wastewater, which is essentially a liquid waste. Now, from liquid waste, when we talk about sludge, it is kind of semi solid waste with predominantly like water content being very high, and water content, moisture content being pretty high, and solids are pretty low. So, but we can use this sludge for like biogas production and land applications and all that. So, let's look at what can potentially be done with this sludge. So, sludge which comes out from the sedimentation tank, whether it is a primary or the secondary, it has to be decomposed because it still has a lot of organic matter. It also needs to be treated for pathogens, bacteria and viruses, because we are talking about sewage sludge. So, people's fecal matter, urine and all that. So, based on, you may have different types of pathogenic bacteria there. So, before you use this sludge for any land application in agricultural farms and all, you need to make sure that there is no pathogenic bacteria present. So, for that we try to do some like a treatment for that as well. So, in the mostly the sludge is also used for anaerobic digestion, because it has good organic matter. So, we can use organic anaerobic digestion sometimes in combination with food waste as well, and we get around 40 to 60% of the organic solids are converted by bacteria to CO2, ammonia and all that. So, sludge digestion process, sludge gets broken up into 3 following forms: digested sludge, which is the stable humus like solid material free of pathogenic bacteria, which we talked about, may contain cysts, eggs of bacteria, etc. Volume is typically 1/3 of the undigested sludge. So, if you start with say a certain volume of sludge, after treatment it will, you will have around 1/3 as like digested sludge. Dried up and used as fertilizers. The liquid part can be taken out, mainly composed of finely divided solid matter and liquid with BOD about 3000 milligrams per liter. It can be retreated in treatment plant along with raw sewage. Gas produced, if you do anaerobic digestion, gas produced has good amount of methane, like 65 to 70% methane, CO2 30%, and you can have nitrogen, H2S and other gases. So, we have to get rid of H2S. CO2, if we can get rid, great, because that's CO2 does not do much harm, but it reduces the net calorific value, because it's an oxidized form of carbon, does not have any calorific value. Methane is what we are really interested in, and methane can be used as an energy source, can be converted to compressed biogas. The government of India has a policy of CBG right these days, which is a compressed biogas plants, and that's can be used in terms of like sewage sludge, food waste and other things can be used for that. So, in terms of decomposition, what really happens? There are 4 steps. Again, I would not, you do not have to really be an expert in this area, but you need to have understanding of what really happens. So, you can, first thing what happens for any of these organic matter is they are big molecule compounds. So, this big molecule compounds get the bacteria, it takes time to start eating them. So, they have to chew them, isn't it? So, they have to start eating. When we talk about stabilization, biodegradation, oxidation of organic matter, all those things essentially means that bacteria is using that organic molecules as food. Now, if it is a big chain molecular compound, although it is there, the bacteria cannot chew it, because it's not they cannot digest it, they cannot chew that. So, what they need to cook it. So, like the one we cook in our home, food, so it needs to be cooked as well. So, what that part happens in terms of what is known as hydrolysis, where things gets kind of made more of a soupy kind of material, much like a milkshake. You have a different shakes, like those things gets broken down into smaller pieces, and then our acidogenic bacteria starts acting on it and produce that what is known as acid fermentation. And after acid fermentation, it will go into finally we'll have the acetic acid, and that after acetic acid you will have potentially acetogenic bacteria, like a methanogenic bacteria, which will convert this acetic acid to methane, methane like biogas, and that's how the reaction takes place. So, we have the first step is kind of acid fermentation, acid regression, or alkaline fermentation. So, these are the major steps. Acid fermentation, acid production is of course, it will acidic in nature, pH will go down. Acid regression, when the acids are going down, so BOD remains high, it becomes foamy and it comes from a top due to trapping of gases. Then we have alkaline fermentation or methanogenic fermentation, where liquid, digested solid and gases get separated. Alkaline in nature, BOD will fall rapidly, large volume of methane gas will be evolving in this case. So, whenever you go for any anaerobic treatment with microbial activities and all, you need to worry about temperature, because they are very sensitive. pH, as I said, it is a neutral pH for methanogenic bacteria. Seeding with digested sludge to have a good amount of microbial population present, so that you know that the reaction will be as expected in terms of rate of reaction. Then you have to mixing and stirring of raw sludge with say digested sludge, just to get the reaction going, because just to have the food and the microbes, they are meeting each other. Otherwise, say if I have food on this side, my microbe is on this side, they don't really have a way to connect to each other, you don't have any degradation happening. So, sludge has pretty high moisture content. For example, sedimentation tank at 95%, secondary sludge is also 96 to 98%, from activated sludge 98 to 99%. So, 95% moisture content means 5 liters solid matter in 100 liter of sludge. So, a lot of water, and the relation between moisture content and volume can be expressed this, where the volume of sludge at moisture content of P1, and that will be the volume of sludge at moisture content of P2. So, we can do some like a moisture content of a sludge is reduced from 98 to 93 in a sludge digestion tank, find the decrease in volume. So, based on that we can, so V1, V2, so we want to get the ratio of that. So, its decrease in volume is around 75%. So, that is what you get, so that gives you a relationship in terms of how much is there. So, other than sludge, some other ways of managing the wastewater, septic tank, which is used in many places, in many houses septic tanks are used. So, septic tank has been you use your toilet, things goes into the septic tank over here, where we have essentially 2 chamber. There are some treatment does happen, and the treated affluent kind of goes into a drain field, but here the treatment is very, very important, because you need to make sure that it is treated enough, so that when it goes to the drain field and goes into the soil and other stuff, it does not have any of the big contaminants to be worried about. So, here this is another example, like from houses, things are coming in into this inlet tank. So, we have some affluent, so that is a like a manhole. Then you have water going out. On top you can have some inspection ports, where you can things can be inspected in. So, septic tank is provided in areas where sewers have not been laid, isolated communities, schools, hospitals. Then sedimentation tank, longer detention time is there, 12 to 36 hours. Both sedimentation and sludge digestion takes place in the tank. Effluent needs to be disposed of in subsurface irrigation. Sludge will be collected and digested anaerobically. Digested sludge is periodically removed as well. Some other ways, there are people are putting this wastewater, untreated wastewater into the rivers. We have seen that happening in India as well. While visiting many of the industries, we do find it being done, like sometimes knowingly, sometimes in like not knowingly, or it like without of because they do not have really understanding of the scenario. So, affluent irrigation or by irrigation, it is also used. Sewage is used in terms of disposal on land for fertilizer and all that too. So, discharge into river or large body of waters, a lake, there is a self purification process. So, water will, because of the aerations and other things happening, the air will be available in which the organic matter will get degraded, and then the DO levels would rise up. But since these days there are so much of organic load coming to this river, so much of affluent going into the river, but then the river is not finding enough time for the self purification process. So, it's again, it's always very busy. So, things because of lots and lots of organics there. So, it needs to have, it does, self purification does happen, but you do not see it very like, you need to put some treatment system in place as well. Self purification, dilution, dispersion, sedimentation, sunlight, that is a physical process, chemical process is oxidation, reduction and all that. So, dilution, dispersion, oxidation, reduction, sunlight, sedimentation, temperature, all these plays an important role when we talk about this wastewater treatment. When the wastewater get discharged into the environment through the way the water moves, that also helps in terms of getting the like DO level going up, back up to keep the water as a healthy water. So, and sometimes you will have some this industrial discharge coming in. Most of it actually they should be treated, but as I said, sometimes they do get discharged untreated. Once you have the wastewater discharge untreated, it actually impacts a huge stretch of river. It's not just the temporary impact, because if you look at here, once you have the wastewater discharge coming in from a pipe, now you have the discharge happening here, but as the water will flow in this direction, you will see the impact coming into the water all the way up to a certain point over here, and we can measure what's the BOD as a function of time as well using that Streeter-Phelps equation. And say if I have a drinking water well over here, where I am taking I extract drinking water for my town water treatment plant. Now, if the concentration at this point will be much higher than what I can really treat it for, which does not meet the pre-treatment standard, I need to basically look at some other option of the drinking water for a while, and or we are trying to treat it a bit treat it earlier that location if possible, in so that we can still continue using it as a drinking water source. So, those issues are there in terms of wastewater. So, as you go of a distance, your concentration of DO will go down because the BOD level will go down, and DO level will start picking up. So, based on that, we know X critical and DO critical, we can find those numbers. So, thank you. So, that is what we were trying to cover in this particular like a beginning of this video. As I said, this material, the bulk part of this material was covered in the previous week, and based on the time we could not include this particular video in the previous week. We will try to get it up there as soon as possible, and the slides, PDF of the slides should be already there. If not, it should be there pretty soon for you to look at. So, again, keep your discussion forum active. Let us know of any queries you have regarding the exam registration and all. You must have got the response from the NPTEL Chennai office, but other than that, if you have any technical query or you feel like any query where we can help you, feel free to put your question on the discussion forum. We will be more than happy to answer it. We try to answer that within 24 hours most of the time. Okay, so thank you and see you in the next video.